A very good morning to one and all, and I'll start the first session. Okay, so today we'll be discussing about some basics, because in what we say discussion or one interaction, we'll not be able to learn all the stuff, and we should not dump all the stuff at a time. And what required actually. So here today, what we learn is what we require. We will see, okay, what are the essential things that a data should be presented in what formats, like descriptive statistics or different ways of descriptive statistics across some using some categorical variables. Okay, so all such things will be observed today. Okay, along with that, in the afternoon session, we'll start the what is the important, I mean, this basic essentials of data visualization. So we will see more on that in the afternoon, but in the morning, what we try to understand is how to build or how to compute basic statistics like mean, median, standard deviation, variance, that and all is there. Along with that, how to prepare a frequency tables. Okay, along with that, how to compute what we say this summary statistics using some grouping categories, and how to construct cross tabulations when the data frame is already ready, when the data raw data is in your hand, using certain categorical variables, and how to prepare or how to construct or how to generate the cross tabulations, and how to compute the total proportions, if you want column proportions, if you want row proportions. Accordingly, each and every requirement can be each and every requirement will be handled in this session. So in total, what I wish to convey is we will be conveying, I mean, we will be covering majorly four aspects: summary statistics, along with summary statistics, cross tabulations. Along with the cross tabulations, you have this frequency analysis, and these three will be handled across the categorical variables. Okay, so because once in a while, we will be able to feel that why can't we present the data using this categorical variable? So that is nothing but we wish to explore. We wish to explore more and more about the data so that we can use those observations, use such observations what we have made, sorry, what we have made using the data, and that can be written for the interpretation part. Okay, so now with this small introduction, we'll start the session. Okay, so I'll share my screen. Okay. Fine. Now we start. This is today's session, what we wish to discuss. Here I'm using a data set called LBW, that is nothing low birth weight data, not leg before wicket. It's not the cricket data. It is about the neonatal data, that newly born babies low birth weight data, where it contains several characteristics that I can show you with an Excel sheet. Are you able to see this Excel sheet? Are you able to see the Excel sheet? Okay, fine. 1 minute. Let me close multiple tabs. It is a little confusing for me. Okay. Excel sheet is visible, right? Okay. If to convey, one or two people can just unmute their mic, or just give me a text box, a chat box message. Okay. Are you able to see the Excel sheet now? Fine. Okay. So 1 minute. Now, when I showed the Excel screen, were you able to see the Excel screen? No, only Word was visualized to you. Word was viewing, right? Okay, fine. I think one by one I have to do. Okay. Uh, Share multiple participants can share the in other formats we can share my complete screen, but here, okay. Oh, I closed this. 1 minute. Okay, first we'll understand in this. Okay, so this data LBW is what we call LBW is low birth weight data, where the data contains several characteristics like a categorical variable which is labeled as low. That means people with categories normal weight babies and low birth weight babies. And there is another categorical variable called smoke, with smokers and non-smokers, mother's habit, and the race they belong to, the age of the mother, and weight of the mother, LWT. PTL is nothing but number of times premature deliveries what mother had, and hypertension is about the BP levels, that mother has the hypertension or doesn't have the hypertension. Uterine irritability, whether the mother has uterine irritability or not. FTV, frequent visits to the doctor, and then number of frequent visits to for delivery, gestational time, and then BWT is nothing but baby's weight. Okay, LWT is nothing but mother's weight in LBS, and BWT is in terms of grams. Okay, now using this particular data, using this particular data, we will try to do some sort of a cross tabulation, descriptive statistics. Okay, so this is a glance to give you a clear picture that how best we can handle the data using all the variables to prepare some sort of a meaningful information out of it. Okay, so generally the first we will understand how to load the data or how to import the data into the R environment. That I yesterday just recall that yesterday uh, we have used we have conveyed, sorry, we have discussed it, sorry for that, we have discussed that different formats that R will support. One is XLS format, the other one is CSV format, SES format, SAV. Okay, SAV is nothing but extension of SPSS file, SAS versions. Okay, so different varieties of dat table, read.table, read.txt, read.xlsx. Okay, different varieties of data formats can be imported with a function called read dot. This may vary according to the file format what you have stored. And along with this, you have another way to do storing in a variable. Let us take dummy I'm creating. Dummy is nothing but read.csv. I can define like file dot choose comma header equal to 2. Okay, so this is one way of doing. Means it will, once you execute this line, once you execute this line in R, what it will pop up a window. It will allow you to choose where you have saved the file. You might have chosen it in D drive, 6-day webinar, a particular data set, LBW. So it will allow you to choose that particular data according to the folder or a pop-up window. That will help you. But the other way to do is, anyway you will be storing the data in that particular folder only. You won't change that particular location of the data. So change, I have stored in M drive, in desktop contents, in K.B.N webinar folder. I have this particular data set, LBW. This is path. Using the file path, we can load the data into a variable temporary storage, that is LBD, low birth weight data. Okay, so M is your drive, colon, double black slash, the main folder. This is another subfolder what I have in this main folder. Every path should be separated with the backslash, double backslash. And last, the extension of the file name must be given. Okay, headers is equal to indicates that first row of that particular CSV file, comma separated value. CSV is nothing but comma separated value. That header, that means consider the first row as the headings of the total data frame. Okay, so here I practice this using the path. Okay, next what to do is, in order to see the first view, quick view of the data, in order to see the quick view of the data, head is one particular function. It will display first six records of the data set what you have stored. Now tail is nothing but the last six records. If you want in between any records, because the data size is around, I think, 189 samples in this LBW, so you can write LBW within bracket like this. You can write LBD square parenthesis. Okay, always the square parenthesis has two arguments. One argument left side the data, the other argument right side the data. Left side the data is about the number of rows, right side of the column is about the number of columns. I repeat, the square parenthesis is to call the rows and columns from any data set. Okay, it is this parenthesis is separated by it is added with a comma operator. Left side of the comma operator corresponds to the number of rows, the rows of the data set. Right side of the comma corresponds to the number of columns. So in order to call, let us take 10 to 37, means I am calling the 10th row to 30th row, calling all the columns. So this refers to that. If I want to call the what do we say, particular column, I can call it as a sixth column. That means this will display only a part of the data set of the main data set. That means it will display sixth column, but not all the rows, but it will display only 10th row to 37th row. This might helpful for filtering options. Okay, but in general, we work with complete data set. Okay, now how to access the variables when you are working with the multiple codes, line by line. There is a function called attach. Attach brings an access to the objects or variables in the data set to directly call. Okay, so this is with the basic introduction that how to load the data set into the R. There are two ways of loading the data set. The next thing is to see a quick view, or there is another function called capital VIEW, view of LBD. Will show you separate data in a separate window of R. Okay, so that we will see. Okay, then what basic measures we can handle. Like yesterday we have covered these things, but some more things that are to be covered in a very extensive manner, that we will have a look of that. So minimum of age, maximum of age, range of age, all these min, max, range, mean, SD, variance, all will give us a single variable representation. That's it, minimum of age. At a point of time, you can calculate age of a minimum of a particular variable. But now, if I want the minimum, maximum, mean, standard deviation, standard minimum, first median, all these things at a time of a particular data set, then it is better to use summary. It is better to use summary. But here, one more question will come. I mean, in this particular LBW data, I have a hypertension, I have race, I have smoking habit. I want to see the summary statistics. Okay, so if a mother has the smoking habit, what is their age, mean age? Okay, mothers, I repeat again the question: mothers who have the smoking habit and who doesn't have the smoking habit, I want to see the summary statistics, that what is their mean age, what is the baby's weight if the mother has a smoking, average baby's weight if the mother has a problem of smoking, a habit of smoking, if the mother is observed with hypertension, like this. If I want all these kind of a query based construction of summary statistics, then this simple summary will not allow you to do that. Okay, because this summary will just give a glance of complete statistics irrespective of all categorical variables. It will tell hypertension variable, no hypertension, hypertension, smoking, how many samples are there, okay, race, how many samples are there, age, mean, median, mode, all these things it will give. But in next session, time period of this particular session, we will discuss that also, that how to display the summary statistics across the required parameters like hypertension, maybe smoke, and etc. But here, one we tell the quantile. The quantile is nothing but here, what is the difference between this calling variable, reference variable, and what is this? I just re-announce. I mean, again, one more time, I announce that the total this elementary kind of discussion is taking because keeping in mind most of the people who are doing graduate level of statistics. So for them, I'm going steady slow. Okay, so hope you will understand that. Okay, now coming to the part of the data, I mean this coding, quantile is nothing but 25th percentile 25th percentile, this 25th percent, 50th percent, 75th, 100, and 0. If you want, this will give you the total 0 at the 25th, 50, 75, and 100. But if you want a specific quantile of a particular variable from the data set, you can specify like this. You can specify like this. I want the 75th quantile of the particular data. I want 25th quantile of the data. Now, we have to understand one more thing here, that I am using different calling functions of variable. Okay, I'm using directly LWT, it is giving my result, but when it comes to quantile, I'm using another thing. Both are equally, I mean, whenever you are not using this attach function, it is better, whether you use the attach function or not, it is better to use this kind of a calling routine in such a way that this dollar symbol will help us to access LWT variable, that is mother variable, from the data set LBD, low birth weight data. Okay, so this dollar symbol is a indexing parameter which will give access to the LWT variable from the LBD data to compute quantiles. Okay, I repeat again, that LWT variable should be called from the data of LBD, for which you use dollar symbol, which will provide an access to take the data from the data frame of LBD and compute quantiles. So here also, if you see, that is IQR is nothing but interquartile range. Interquartile range is what? Q3 minus Q1. So the third quartile minus first quartile. Again, here also we are calculating the calculate. We are instructing. In the yesterday's first session, we have seen that R has a greater than symbol, that is a prompt button. What now? So we are instructing the R with a command that IQR, compute interquartile range from the LBD data set by taking LWT. Okay, this is the meaning of that. Okay, now we'll take all these things, and then we'll take all these things and then we'll do it in our studio. Okay, I think now for a second I'll stop sharing and then I'll share this R Studio. Okay. Now, so this is the view of R Studio. Okay, this is the view of R Studio where this is paneled into 4 compartments. Okay, people who have worked with SAS, okay, they may get a recollection that it looks like a SAS panel. Okay, SAS is also the same kind of a appealing, what we say, the window presentation. So this now, what we are having here is the cursor where it is blinking now is called script area. You can write all the codes here. Okay, let us take like lvw is equal to read.csv like this. I can, okay, once you write half of it, the list of functions related to it will get displayed. Okay, now like this, what and all we are planning to execute the program, execute the data analysis, we can scribble here. For a while, for example, I'll show you the recently done thing. Okay, so this is the script I have written. So this is script. This is like a notebook for us. Okay, we can store this, and whenever we require, you can open it and start running using this run icon. Okay, either you can see this that it is a control enter, or you can see when I place the cursor there on the run icon, it is displaying a message that run the current line or selection, okay, or control enter. So place the cursor at a particular command which you wish to execute and press control enter or press run button. Okay, now the extension of these script files is .r. You can see here. Okay, I can increase the font size, view, zoom in. Okay, it has increased the font size also. I can adjust this panel. Okay, we won't go much for this. Okay, so this is what we call script environment, and this is the R console. Generally, R console will become part and parcel of this R Studio. So in order to work with R Studio, you need to install both R and R Studio. Okay, so now this is what we call environment of the R. Whatever you do here, let us take for instance, I'm calling this particular data. Automatically, see, once I executed this particular command, the data set is loaded here. Now, in order to see what sort of data set it has, I can click on this. It will give automatically. If you see here, by clicking, it generated a command called view of SP. Okay, it generated a command called, just I made a click on this particular SP variable, automatically a code, a command is generated, capital VIEWSP. Now we are able to see the data in a separate window. Okay, so here, just scrolling down, I can come to see the complete data set. Okay, so this is for whatever the computation. Suppose if I want to make uh, any summary computations, okay, that we'll see when we do this thing. So whatever the computation of mean, storing the computations into a particular variable, all these things will come to this environment. Now this panel is a comprehensive note of multiple things. What files you have already from your local library. Okay, and then the plots, what and all actions you do, let us take scatter plot, all these things. This will give me, sorry, there is some error. Okay, no issues, because I have not used an attach function, it has given. See, this will give me, this is the problem with, if I am not using attach function, I should use sp dollar sepal dot length, sp dollar petal dot length. Okay, so this kind of error will come because the data set is not taken exactly, I mean, the variables are not accessible without the file name, data file name. Okay. If I use attach function, if I use attach function, then I need to use dollar symbol. Okay. Now, this is the plots. I can click on this zoom button to maximize the window to see very clearly, and I can close this. And at the same time, I can export this image. You want to save this image as a PDF, or you want to copy it and paste it in Word separately, or you want to save this as an image. Okay, when you want to click on the save this as an image, it will ask you in what format you want to save the file. You want to have a TIFF, you want to have PNG, you want to have a JPEG, or any kind of a file, EPS file, because most of us will work with the LaTeX version. Okay, there we need to call the images with encapsulated this EPS versions. So directly you can save the image into EPS version, and then accordingly you can increase the width and height of the image by maintaining the aspect ratio. Once you change this, update the preview, and then whatever the file name you want to have, I want to type this as a scatter plot. Okay, and then you want to see the plot after saving, where it is stored, and how you want to see how it is being picturized very nicely. That and all can be seen, but you can press the save button finally. Okay, for meantime, I'm not doing that. Okay, you can store into the directory also where you want to store directly. Okay, I want to store in research, I want to store in analysis 2020, something like this. I can select the directory where I want to save this image, and then I can click on save button. Automatically it will go and save there. So this is one advantage. Now coming to this is called a clean button, a brush. If I press this, it will, or you want to clear all the plots in history. So history of plots, what and all so far generated, will get cleared. Okay, fine. Now, what is this packages? Packages stands for the packages which are installed already in my system, in my R environment. So these many packages I have already installed. I have got when I installed R. Okay, I said yesterday that when you install R, some of the packages do come along with that installation, but apart from that, I have installed the G gallery. That is nothing but grammar gallery. I have installed GG carplot, which is a visualization of a correlation matrix. That is grammar of graphics. First GG stands for grammar of graphics. Okay, and I have installed glue. I have installed miscellaneous. Like this, I have installed many other packages which are required for me based on the need. Okay, I have installed library bootstrap. Like this, suppose if you want to install a new package, like you have to click the button. I'm at present we are on the internet. Okay, before you start installation, you have to check whether the internet is on or not. Okay, you have to click on the button install. It will show you a repository CRAN. That should be by default. Whatever the package you want, I want a package called, when I press R, these are all the packages available on this particular R starting. I say color river, color, see, or color brewer. I want this package. You can have a choice. Are you able to capture the what I'm trying to convey now? Okay. If I'll make a very slow pace. Okay. Now what I did is I want a package of R color brewer to be installed. Okay. R color brewer to be installed. Now, if I type R capital C, then I'll come to know many packages, but I'm pressing on one more word, one more letter, then I can have the clear picture that what and all packages which starts with the letters RCO. This is my requirement. I got it. Then click on that. Okay, R color brewer. Now install the library. So it will currently I'm working on 4.0. Okay, so it may vary from you because you might be having 3.5.2. You may have 3.6.3. Okay, but by default, this install dependencies will be checked in. Do not remove that, let it be. In yesterday, we have seen a sentence format of installation. Okay, that is install dot packages within double quotation or color river comma dependencies is equal to true. Okay, but instead of that, the main advantage what I felt in practicing in our studio is that that kind of a cumbersome, no need to select the mirror here, automatically it will choose, because it is from the cran repository, it is from the cran repository, automatically it will choose the mirror and it will start installing the package. Okay, okay, is everything clear? I think so. Now click on install button. Now, once you start click on installation button, this kind of icon will get enabled. Means the installation process is going on. Okay, so now once the installation process is going on, I can see I can see that package. I will get a message called package or color driver successfully unpacked. Means it is installed properly. Now I can call that package, that library now or color brewer. Once the package is installed into your R environment, automatically when you start typing the letters, first letters of the package, it will display. So R color brewer. Now I'm running this. Hereafter, I can I can use all the functions of whatever the R color library has. If you want to know what actually it has, let me go to help function, type it here, R color brewer. See, now I'm explaining the another menu of this particular R Studio, that is help. In order to see a particular package syntax, what functions it has, right now there is one package called summary of tools. We will be using that. Summary of tools has 4 different functions. One is frequency, the other one is C table, the other one is descriptive, the other one is data frame summary, getting the summary statistics from a data frame. Okay, so how the total description. So using this frequency of this particular thing, okay, now I get this kind of a table. Okay, if I don't want NAs, I can add comma NA dot RM is equal to false. Okay, ignoring missing data. Like this, you can generate of your own requirement. So this, there are ready-made manuals for every package, every function. Okay, or color driver. If I click on this, now I got this syntax, brewer.pal. Okay, display.brewer.pal n comma name. These are all the general syntaxes. Now each argument, what it stands for. N is nothing but number of different colors in the palette. Minimum 3, maximum depending upon the palette. There is no restriction. Okay, name, a palette name from the list below. Okay, they have given some list. Okay, like this. And this is the example. But I mean, a quick overview that whatever the, okay, so whatever the, I think viewer is also welcome. Okay, so like this, whatever the question you have regarding a particular package or an argument, then you can get the help. Find in topic. I want to, any particular, suppose I'm using, what you say, this is scatterplot 3D. I want to know the function of this scatterplot 3D. First I have to call the package, then I can choose a topic of that particular within the package. Okay, so this, in this way we can easily go accustomed, we can get accustomed, we can get used to the R library. Okay, now what we have seen here is, let me paste that, let me remove, in order to, yeah, now we'll start running each line so that we'll able to understand the thing. Okay, as of now we are not doing any graphs. I can adjust this window so that have a better view of the table. Now all these commands I want to clear off. Here I can place the cursor on the R console, press Ctrl L. It is nothing but clear the total thing. Okay, now I have a fresh page in the R console. I don't want to execute this command because I'm using the path now. To disable this command, place the cursor on the first before the first letter of the command and press shift 3. It will create a hash symbol. Hash symbol will act as a comment. Okay, whatever you want to say. Now I have used listing first 6 and last records of the data. That is a command, so that I will be able to understand what head is, what a tail is, what is view, all these things. Likewise, I said basic measures. Okay, so all the comments can be added for each and every command or a line of the R code for better recollection in future perspectives. Okay, now let us load the data. Now data is loaded, you can see here. Earlier there was only SP, now we got LBD, which is of 189 observations of 10 variables. Okay, now let us view the first 6 rows of the, sorry. Let us view the first 6 rows of the data set, that is head and tail. Let us take that run. See, that is the problem. Yeah. This 1, 2, 3, 4, 5, 6. The first 6 records for this head and tail here 184, 185, 186, 187, 188, 189. So the last 6 records of the data and first 6 records of the data. Now you see, you have low with a normal weight and low birth weight categories. Smoke, smoker, non-smoker, race, black, white, others. Age, difference, different. It's a continuous in years. LWT in pounds, LBS. PTL, premature deliveries. Okay, hypertension, no hypertension, and hypertension. You can see here also. And frequent visits to doctor. Okay, and this is the birth weight of the baby. Last column is nothing but the birth weight of the baby's birth weight. Okay, so now, but to have a complete view of the data, either you can type capital V as in view, or you can click on this LBD. Okay, now clicking on running this, a separate window will get opened where I can see the complete view of the data. So this is the total structure of the data where I have 10 varied columns and 189 rows. Okay, now we have to see one more thing. Whatever is displayed, okay, it will show here, showing 1012, 114 of 189 entries of 10 total columns. See, if I change that, that will get changed. So where you are currently positioned, that also will come to know. Okay, fine. We'll close this. We'll close this also, and we'll close this also. Right. Now, let us use, to have a better access, let us use this attach function. Now, it is attached. All the variables are to the local R library. Now, I mean, data sets has been brought to the total R data framework. Now, let us start with the basic things like minimum, maximum range. Now, this is the minimum, maximum, and range of that. Now, let us start with summary statistics like mean, standard deviation, variance. Place cursor anywhere. If you want to place cursor anywhere and run it, but if you want to have only one particular print of the outcome, then select, I want mean alone, then select that particular command and then click run. It will display only mean. Okay, if I want both mean and standard deviation of the data, then select those two and click on that. So the mean weight of mothers is 129.82 and with a standard deviation of 30.57. Okay, now I want all the three, then no need to select all the thing, but just place the cursor in that particular line and click run button. It will display mean, variance, and the mean standard deviation and variance. Okay, so this is what, and then now, okay, now we will do the summary. Let us see what summary will tell us. See, summary is giving all this information. I said summary will tell us the length of each categorical variable and its class and mode of type of the data framework. And now coming to age, overall average age of 189 samples is 23.24 years. Okay, now median is 23 and minimum is 14, maximum is 45. So the summary has a composition of minimum, maximum, first quartile, third quartile, median, and mean. Most of the time, these two to be verified, median and mean. Why so? If mean and median are almost close, normal, symmetric, we will get a bell-shaped curve. Median and mean is in the center, and equal number of points are distributed equidistantly on the left-hand side and right-hand side of that particular median line. Okay. Now the third quartile and first quartile will tell us the next band of the data points. So 19 to 24, 23 and 23 to 26. If you see that quartiles also, they are also equidistantly positioned from the median or a mean. So this shows that there is no discrepancy in the data towards extended more towards left, extended more towards right. Okay, so the data is positioned with equidistant portion of data points. So what I'm trying to explain now is exploring the data with some sort of a support of graphs or descriptive statistics. This is what we call exploratory data analysis. Okay, exploring the data as much as possible using the basic tools like summary statistics, graphical presentation, we can understand a lot more out of the data. So this is now, hope you have witnessed it. This is what we are trying to explore. Hope we are trying to explore that minimum range is 14 to 45. The mean and median are close enough, indicating that the data is symmetrically distributed. The position of first quartile and third quartile with respect to median have equal distance. Suppose if the median is, let us say, 30. What does it mean? Sorry, if the third quartile is 30, what does it mean? Your right box, that means the median, the distance between the first quartile and median, mean and third quartile is not uniform. That means majority of the data points are tending towards the right side of your total distribution, leading to a slight skew distribution of the age parameter, age variable. So like this, basic summary statistics will give us a clear-cut note that how to visualize using summary statistics. Okay, coming to this. Yeah, that is what we have, what and all we have discussed it now with respect to skewed pattern. You can see here. Okay, what is this? No, minimum is 80, maximum is 250, too big range of that particular mother's weight, and mean is 130, around nearly to 130, and median is 121. There is a slight deviation from mean and median. Data is not that symmetric with respect to the mother's weight. This is the in total overall observations. This is overall observation. The first quartile is 110, the third quartile is 140. Now, if it is 130, if you take this as 130, 110, 130, 140. Okay? Okay? Now, I'll do one thing. I will create a box plot of this, box plot of LWT. Yeah, look at this. Now take the support of this variable. Where is that? It is here. Yeah, the first quartile is 110. The median is one. The mean is 129. That is, median is 121, and the third quartile is 140. You see the area here. The right side of the median is maximum, and the left side of the median is minimum. Means majority of the data points are on the higher side of the median, and a few samples are at the left side of the median. And there are some extreme, I mean, outliers. I mean, there are some weight of the women whose weight are above this upper whisker, that is maximum to this is the maximum value, this is the upper whisker. Okay, so this is one kind of indication that box plot will tell us whether the data is symmetric or skewed. Along with that, whether the data has outliers or not. We will talk more about box plots at the data visualization part. Just I want to make you aware that how to connect the summary statistics with this graphical plot. Okay, now fine, we'll move a little uh, next to that. We'll see this quantile. This is the overall quantiles of the data with respect to mother's weight. Okay, if you see this, this median is nothing but your 50th quantile. This is the first quantile, third quantile. Okay, so like this, if I want to have the 25th percent quantile, then it gives me the first Q1, and this may give the Q3. Okay, now coming to this interquartile range, IQR, you should be very careful. I repeat again that R is very case sensitive. Okay, you should use capital I, capital Q, capital R. If I use I, small q, small r, it will result in that function is not available. Let me show you that IQR. When you type itself, it will show you that you are looking for this one, or that means it will indicate as you are correct doing some mistake. Okay, LBD dollar, I can take off, let us take BWT. Now, once I call this, yeah, one more thing I want to tell you that when I use this LBD dollar, it will list all the variables which have stored into the present time R library. I can select to overcome the typo error or case sensitive manner. Once I execute this, it will show could not find function IQR because it is case sensitive. It is defined in all capital letters. If I redo this by writing in capital letters, then it will get executed. The interquartile range of baby's weight is 1061. Now, okay, so like this, some basic measures. We will go a little ahead now. What I'll try to show you is, I will introduce you to a new command or code or sorry, command or function that it is called par mf row C of 1 comma 3. What does it mean is partition the total plot. PAR is nothing but, let me clear this. Okay, let it be. Okay, PAR is nothing but partitioning the total framework of this plot view and main frame into number of rows. Number of rows, how many? That is C of, this is a vector, 1 comma 3. I already said always left side is a row, right side is the column. I want one row, but the panel should be divided into three independent, I mean, three columns. So let us do that. Now, this has created, but it won't show us visually. But when we generate the plots, we can view the three thing. Now I'm using Boxplot. Now it started. So first function, first line of this has positioned the graph in first panel, first split of the panel. Okay. Next is this, and next is this. Okay. See this. Now the first panel of this total partition is about mother's weight. This is about baby's weight, and this is about age of the woman. Okay, So like this, if you want to turn off, suppose in next time, if you want to repeat any, I mean, if you want to present one more graphical plot, now if I start, let us assume that this is one more line of the graph, I mean, one more plot of the data set. If I do that, automatically still that panel will be in active mode. Okay, still that panel will be in active mode. To turn off that graphic versions, there is a function called graphics.off. Okay, graphics.off will clear all the activated functions used for graph, and it will clear all the images. Okay, now there are no images. Okay, there are no images. I can start fresh. Now it will display in a full window. Now if I use this again, framework will get splitted into that. Okay, when we start generating multiple images, there is a icon here which will show to allow us to go back to the previous plot, to come to the present plot. Now once we use, I repeat again, we can generate multiple plots, right, over the line of coding to the computation. We will be generating multiple plots. To have a recollection and understanding, you can use this arrow button, previous and next. This will help us to see what we have generated, what next to be generated, so on and so forth. But if we use this graphics.off, what will happen is all the images which will be on a temporary mode in this plot view will get vanished. See, there are no access. All the images got vanished. And again, you have to run for that. Okay, so it is better to have, if once the coding is pakka, I mean, very well set, then save that image. And once you want to move for the further full view of the plot window, then better use graphics.off, so that by the time you could have saved all the images. Right now, we'll move to, yeah. Now, what we did here is, we wish to see, we have visualized the three continuous variables of the data set into multi-panel box plot. Okay, multi-paneled box plot in a multi-paneled window. Okay, this is what we can do. And we can see that baby's weight is symmetrically distributed from the lower quantile, first Q1 to Q3, and age of the women is almost symmetric. And but in a mother's weight, there is light skewness. This is the overall observations. We cannot conclude out of this because our orientation is little different. Okay, next we'll move to some more parts of the thing. Okay, now what we do here is, we need some more space. I can adjust it. Now a question, how to display summary statistics using a categorical variable? Here we have categorical variables like smoke, hypertension, HT, race, okay, like this. So I'm using hypertension. I wish to by means by is one function, by HT categorical variable of the data set LBD, create, generate, or compute summary statistics. That is what this line stands for. By is a function which will help us to indicate, by means of this categorical variable, generate summary statistics for the data set LBD. Okay, run this. We have got, see, a huge report will come that LBD, this is the total view of hypertension category. Hypertension category, that there are 12 samples in hypertension. I mean, out of the 189 people, women, there are 12 women who have hypertension and 177 who doesn't have hypertension. And of those 12, okay, of the particular 12, the age category is 17. The earlier one was the overall age category, that was 14 minimum. The mean is 22.92. Here, with the people with no hypertension, mean is 23.26. So this is one observation, that women who doesn't have hypertension, their their age level is 23.26, and people with hypertension now 22.2. Now we'll make some more interesting points here. Mother who have this hypertension, their average weight is 157.5. Coming to no hypertension, it is 127.9. Okay, so this might be due to the different factors. We will no need to conclude now. We're just making observations. Now we can replace this. We will replace this with smoke. Okay, let me see what smoke category will tell us. This is a smoker table, and this is the non-smoker table. This is non-smoker table. Okay, when coming to the non-smokers and smokers, okay, babies, but yeah, here where we are, I'm interested in baby's birth weight. Okay, in non-smoker category, okay, the mothers who do not have the habit of smoking, their baby's average weight is around 3 kilos, whereas the mothers who have the habit of smoking, their baby's average weight is 2.7 kilos. There is some sort of a impact. This will raise a question that can we conduct a cross tabulation between the normal weight babies and low birth weight babies with respect to the categorical variables smoking and non-smoking? Doesn't exist any association. So the exploring data will tell us some sort of a questions that are to be clarified, and then it will go on like that when once we start analyzing the data. Okay, the other way of doing is to use psych package. Okay, I'm using a function called describe by. Describe by is nothing but to using which. Okay, oh sorry, I should call the package now, sorry. First I should call library, and then I should call describe by. Now this describe by will give this picture like this. Describe by will give the picture like this. All the category, all the variables, okay, and then variable 1, variable 2, variable 3, and 10. Number of variables in low birth weight, 59, and then mean, because these are all categorical variables. Star indicates the category that the no means will be computed. For categorical variables, mean should not be computed. Okay, but using the categorical variables, we can compute the mean. That I'll come later. So this is the total summary what we have generated. And we have another function. There are very wide variety of functions to generate summary statistics. One we have seen this by, the other one is described by, the other one is just summary of, and then we go with aggregate. Aggregate, what I'm trying to do is, here I'm calling only the continuous variables. I'm binding them as one frame of data. Okay, compute, one frame of data. Using this frame of data, now compute the aggregate values, that is mean. Okay, I'm indicating the mean alone here, indicating mean, and then across the birth category of the baby, that is normal weight or low birth weight, and smoking status of the mother. If you see here, low birth weight category, non-smokers, the average age is average weight is 120.13 lbs. Baby's weight is to 2049 grams. Age is 21.79 of the mother. Normal weight, non-smokers, little higher, see. Okay, and low birth weight smokers, 2143 is the baby's weight. Normal weight and smoking 3000. So in this way, we can create summary statistics across different categorical variables, so that we can witness that if the if the baby belongs to low birth weight, if the mother doesn't have a smoking habit, the average baby's weight may be very too low. Okay, this might be, here we cannot make a general decisions out of it. All these summary statistics will help us to describe the phenomena which is observed in the data. Later, we have one more phase of the data in statistical methods is that inferential statistics, where we will take this support of descriptive measures and speak with a validation in that inferential statistics that will come across tomorrow. Okay, now, okay, fine. I'll stop here. Okay, I'll stop here. Now, what we can do is in the afternoon session, I will tell you some more cross tabulation codes because we should maintain the time. We will see how to create a cross tabulations, how to compute total proportions, okay, how to compute row proportions, how to compute column proportions with a single line of R code that is so easy to work out. So in the afternoon, we will do that, and then we'll start with basic data visualization. Now I will allow all of you to raise your questions for 5 minutes because there might be some other events for the college people, so that we should not restrict that. Okay. Now there are questions. Let me see. If you have any questions, slowly, one by one, well, let me take that question. Okay, there is some suggestion that we'll see. Thank you for your kind words about the package. Okay. Yeah, where somewhere the question? No questions today. Yeah, sir, in my PC package or not installing. Check the internet connection. Check the internet connection. Check the code. Okay. Uh, okay. Then there is one more question, sir, about courtesy skewness and its range. Yeah, definitely we will do that. Just simple use skewness of that particular thing. But generally, what we prefer is the skewness and courtesies will be observed with Boxplot. Okay, skewness and courtesies will be observed with Boxplot. Any other? mm, Before installing, do we need to know the compatibility? Not necessarily. If the package is not compatible to the R version what you have, it will tell it is not built for this, suitable for not this package. In Google, I mean, when you start Googling it, you will come to know which package is for what kind of a version. But in general, it works. It works. How to remove the outliers from the data? Okay, how to remove outliers from the data is the question is very simple, but the next question what I raise from my side is, do you really need to remove the outliers? Because because you will be losing the data. If the samples are large, let us take 250, 189, and there are some multiple, because removing data is not that easy. I'll tell you the sensitivity of the data here. In the present data set, what we have taken, low birth weight data, when you take the variable, categorical variable race, it has black, white, and others. There are around only 10 to 12 samples which are related to others category of race, and 40 to 50 samples belong to black, and white race are large samples. I mean, I am answering your question in keeping the data sensitivity part. Okay, suppose if you have observed 4 to 5 observations as outliers, and all those 5 observations belongs to the others category of race, then what you do? Will you remove? No, you should not. If you remove, you are weakening the data, weakening a portion of the data where you cannot use that race category thereafter. Okay, so it should be dealt in a proper way, that transformations to some extent. Does if you go, I mean, if you really wants to use that variable, if you want to have that, but when you build modeling, automatically that will take care of in different modalities of the uh, what do you say, this iterations. Okay, but in general, it is not suggestible when you have multiple categorical variables. It is not suggestible to remove the outliers if the data doesn't have any categorical variable that we will take in, especially in general regression. Most of the data will come with all continuous variable, but it is a combination of categorical also. But if we come across with the continuous variables only, then if you really require, assume take it that it is an outlier, then you can remove it, but only to the proportion. There is a concept called trimming. Okay, no need to remove the outlier, just use trimmed mean. It will give you, by extracting the left 10% of the data, right 10% of the data, it will give only the exact distribution of the variable what you have taken. So I suggest you use trimmed function rather than removing outliers. Okay, thank you for your thing. Yes, yes, that is what today we have shown. Is it possible to import Excel file? I have used a comma separated value. You can use read.xls, that's it, or read.xlsx. Okay, using that you can do. Syntax to add a comment. Syntax to add a comment is to define a line, a command as a comment, hash symbol. Okay, for normality, what should be the range of skewness and curvature? Skewness should be equal to 0. Okay, the other will take care of. Curtis says, I think it is -3 to +3. I think so. Sorry, -3 to +3. I think so. Yeah. Can you please? Yeah. Regarding this request made by most of the participants to share the PowerPoint or what are the documents what we are talking, all at one stretch you will receive at the day 5, end of the day 5. Okay. So kindly be patient because all our codes are openly available. These are all not my own copyrights. Okay, R is for everyone. That's why every code will be available to you, but the way to use it depends upon your individual logical brain. Okay, don't use whatever the codes which you have given as such, because the requirement of that particular data will make us to reframe the R language coding to the appropriate manner. Yeah, data is openly available. LBW data is openly available. Okay, you can get it. Okay, thank you for that. We are able to maintain the real classroom teaching. Thanks for that. Okay, understanding the box plot. Madam, we will do this in the afternoon because we will be starting this basic data visualization where we'll see histogram, box plot, everything. So I will elaborate more on that. Okay. Aggregate function is for obtaining the summary statistics. See, aggregate is one, summary is one. By summary will become argument in the by function. Okay, like this, there are different versions of this obtaining summary. So one such function is aggregate. Aggregate, in the last argument, you have to specify what value you have to display. That is mean, standard deviation, standard error. Okay, like that. How to know the number and number of name of the variables in a file? There is some, I think, str of the data file name. It will give you the total description of the data. How to edit alpha 1 instead of alpha? I think you giving a label x label. I mean, if you have the 2D plot, x-axis and y-axis, that alpha 1 variable name uh, can be defined as a label, x label as alpha and y label as some other whatever you require. How can we find different trend lines with R square and um, separately for R each trend? Okay, how to find different trend lines with R square and regression lines separately for each trend. We can do it. We can do it. That I'll tackle with regression when we have the session of regression. Okay. because here there are many budding people, they will get confused of these questions. I am taking the questions which are relevant to the present context, and the questions I remember, I am noting the questions, okay, for next sessions. Now, LBD is the variable where I have used it for temporary storage in R, but LBW is openly available. Okay, Debashis Dave Kamshi Com Skills University. Hello, sir. And then, yeah, the same question. I think the same madam is rising again. Sir, Vika or R, Vika tool or R. Madam, I have not worked with Vika when I don't have a convenient way of exposure regarding one software. Sorry, I admit myself not to speak, because once we don't know the pros and cons of a package, we should not compare it and say something what we know. Okay. I don't know why you are sharing your email IDs. I said you will receive this presentations at the end of the day 5th. Okay. Of course, we should remove the outliers, but to some extent in a balanced way. That's why I suggested instead of removing, you use a function called trim. Okay, how to compare F calculated value in RStudio. See, most of the present day scenario, all the calculated values of T, F, chi-square, any kind of a modeling aspect is compared using P value. Okay, tomorrow morning, what we are going to have is after 3D data visualization, when we start with inferential statistics, the first and foremost thing is what we have to understand, the concept of p-value. There are many misconceptions, there are misleading interpretations, what we are witnessing in majority of the articles which are published worldwide. Okay, missing values, yeah, that there are many packages like mice package is there for each categorical type of data. There are wide variety of packages available, so using that we can handle the missing data. We can replace them. Imputation, multiple imputation techniques are available, that using em algorithm we can impute the data. By function is nothing but, see, by a function indicates that compute the summary. The third argument is double quotation summary. By calculate the summary of the total data set of LBD by this categorical variable. That is the meaning of that. That is the way to understand the by function. Okay. Oh my God. LA, no, it's not LAW. I don't know what is that LAW. There is no variable called weight. There is a variable called LWT. Okay, that's why you are not getting. There is a spelling mistake there. Yes, you can write both. You can write code for ML algorithm, and you can write separately for this thing. Okay, then what is the timing of afternoon session? That is regularly all the days. Morning session is from 10:30 to 11:30. Afternoon session is from 3 to 4. Okay. Advantages of R when compared to Python. Okay. So each package language, it has its own advantage. When you want to work with machine learning, deep learning, and like what we say, this natural language processing, then you have some more languages other than R and Python. Okay. And yeah, so there is Spark Scale, how to handle large data sets, unstructured from structured, using Spark, MapReduce, Hadoop, different. So each language, each software has its own purpose. So comparison in a mere sense may not work out in a proper way. But I claim that data visualization in Python is good. Okay, and machine learning algorithms is best widely used in Python. Okay, right. So again, there is a one more request to share the PPT. I repeat once again that all the PPTs, all the material will be shared to you by the end of day 5. Kindly be patient, right? If okay, if there are again there is a request. Fine. Okay. Uh, if there are no questions, we will wind up now. We will assemble again by 3 p.m. today. Okay. And be sharp by 3 p.m. Okay. Right. Thank you. Vijay, you can conclude now.